In this next example, we have 16x squared minus 25y squared. Since there's a minus between those two terms, we can assume that this is a hyperbola, and it's equal to negative 400. So we have x squared minus y squared equals negative. So we should first of all establish that this is a trans y. Okay, that negative makes this a trans y hyperbola. So it's going to be along the y-axis. We want to divide both sides by the 400. So we end up with 16x squared over 400. We want to simplify that fraction. We have 25y squared over 400. And that's going to be equal to negative 1. So simplifying this ratio, 16 over 400 has a common factor of 16. So we end up with 1x squared over 25 minus 25 over 400 shares a common factor of 25. So we get rid of that common factor. We get y squared over 16, and that's equal to negative 1. So our a squared is 25, our b squared is 16. So we can work out our value for a. A is equal to 5, and b is equal to 4. Okay, so that's going to give us our x and y vertices. So we go 4 up from the center. Okay, there's no horizontal shift, so the center is going to be at 0, 0. And then we have our vertical center is going to be 4 up, 4 down. So our vertical vertex is going to be at 4 up, 4 down. Our horizontal is going to be 5 to the right, 5 to the left. And this allows us to generate our rectangle. So I'm just going to mark the corners of that rectangle. And that rectangle will allow us to work out the slope. So if I kind of sketch in that little rectangle here, the diagonal of that rectangle represents the slope ratio of b equals 4 and a equals 5, or a slope of 4 over 5. So I'm going to sketch in my slope. I'm going to put my ruler in here. I'm going to sketch in my slope. And knowing that this is a trans y, I know that I'm going to use the vertices along the y-axis as the vertex of my hyperbola. And so using the vertex and the asymptotes, I'm just going to sketch in my hyperbola. So there, I'm just going to follow that the asymptotes the best I can. It does need to be a work of art, but as long as you start with the vertex, show the slopes of the asymptotes. Again, use that little rectangle will help you get the ratio of the rise and run, and then follow the asymptotes, and we have our hyperbola.